Hi, this is Eric from Second Square. This is a short video on how to interpret a shift report from a drilling and blasting operation. The shift report has two pages. The first page looks like in front of you. It has the registered start time when Edge was started for this shift and the end time when Edge was ended for the shift. In this case, it started 6:45 in the morning and ended just around 6 p.m. in the evening. Through this shift, Edge has detected 13 holes have been drilled. The entered rig identification, in this case, was DR109, and that has been entered by the operator, so we can see which rig the Edge was recording on. Up on the right-hand side here, you will have the customer's name. It's been blocked out for confidentiality reasons. On the drillers, you see the name of the driller that was operating Edge at the time, and the blast zone where the driller or the rig was operating in this shift. Here we have the graph that shows how the hammer has been operating throughout the shift. The top set of the graph shows the frequency expressed in beats per second by the hammer. That's what we see in this part of the graph, and here as well. The bottom part of the graph shows the amplitude or the energy of the hammer that Edge has recorded. The green line shows positive energy and the red line shows wasted energy. I'll go through a little bit what we would like it to look like. So, the background here, when the background is a bit gray, that means we have drilling. So here we have drilling, here we have a rod change, here we have drilling, here we have probably moving the rig to another hole. Here we have a rod change, drilling again, etc. What we're trying to find is the black line here being as high and as stable as possible. That means the frequency. So what we would like to see is something that looks like this, for instance, or this, which is very stable. What we don't want to see is a frequency that looks like this. I will compare two rods now, or two holes, and you will see the difference of where the weight on bit has been better than the next. So I'd like to focus on two specific rods. Here, which we started the drilling around 3 o'clock in the afternoon, you can see a very stable frequency for the first rod and a stable frequency for the second rod. We can also see a good deal of separation between energy breaking rock, which is the green line, and the red line, which is wasted energy. This rod here probably took about 15 minutes or so. Now, compared to this rod here, you can see this line is much more shaky. That means that the frequency has been very unstable. And you can also see that here we had very little, if no, separation between the green line and the red line. That means typically that the weight on bit has been too low, and you can see that the time to drill this rod, a 9-meter rod, is more or less half an hour, whereas the similar rod was drilled here in about 15 minutes. So we would like to see this and this. We would like to avoid seeing this, which is an unstable frequency, and a lot of wasted energy. So that's some interpretation of the graphical of the graphs representing the hammer. I'm going to go to the second page now, I hope. Here we are. So this is the second page of the shift report. Up on the left-hand side, we have some statistics on how the hammer has been working. First, we see the average frequency of the hammer. So this through this shift, the hammer has been operating just below 29 beats per second. The maximum frequency achieved was about 30.5, and the range of the frequency between 27 and 30.5 roughly. That means that the spread of the frequency has been about 3 beats per second. We would like to see this number as low as possible. Typically, if it can be as low as 2.5, that's great. Anything above 4 is quite shaky, so we would like to see this quite low. Of course, we would like to see the maximum frequency being high, as well as seeing the average frequency being high. So that's what we're looking for. The next thing we're looking for is the effective drilling time in the shift. In this particular shift, which is about 11 hours of recording, the drilling time has been 6.5 hours and the non-drilling time about 4.5 hours. That means that about 60% of this shift was used for drilling and about 40% was used for other activities. Further, on the right-hand side, we have a number of statistics. They are typically the kind of the input information that the operator has entered in the Edge system. So, first of all, the operator has entered that this is DML rig. They've indicated that they're using 6-inch hammer. They've put in that the bit size is 203 millimeters and the insert diameter is 19. A single rod has the length of 9 meters. They're using 2 rods per hole. They've set that the minimum drilling time per rod is 360 seconds or 6 minutes. They've set that the minimum time it will take to change from one rod to the next is 15 seconds. They've entered that the minimum time it will take to move the rig from completing one hole to the next hole is 12 minutes or 720 seconds. And Edge throughout this shift has detected 25 rods in total. We say that there are 2 rods per hole, hence 13 holes have been detected. The rest here is the time zone entered, which software version was used by Edge, the serial number of the computer, and the wireless channel being used for radio communication with the sensor, the ID, etc., etc. But broadly speaking, the things that are interesting to look at is the graphs to see how stable the frequency has been and how much energy has been used to breaking rock. And secondly, we would like to see high values on the frequency and would like to see a big percentage of the shift being used for drilling activities. And that's a short introduction to how to interpret the Edge shift report. Thank you very much.